Okay. Привет, Governor Russia. Меня зовут Konrad. Спасибо за приглашение. So, this is all the Russian I can give you today. So, who of you, hands up, knows the quote from Tolkien's Lord of the Rings? One ring to rule them all, one ring to bring them into darkness and bind them. Okay, so I don't want to drive anyone into darkness today. I actually want to give you a little bit of enlightenment about a pretty neat Go utility called GoGenerate. I'm the lead architect at October. October is a social network designed for the attention economy, which is based on the fact that human attention is a scarce resource, and as such can be treated as its own currency. So it's a pretty straightforward platform. You can post links, images, text, but more importantly, you can decide if you want to post something with your real identity or anonymously. So you can also earn coins when you compose good content, but also reward other creators for their content by tipping them. Our whole backend is written in Go, especially the API, and this has given me lots of challenging and interesting projects, and I will be talking about one in particular. So let's look at this statement here. Go doesn't have generics. Let that sink in for a moment. The way you may react to this has probably a lot to say about how long you've been programming with Go, because usually the people which are most annoyed about that are people who don't even code in Go. If you've been with Go for a long time, then you don't even care, possibly. And if you've just started out with Go, you might still struggle with this a little bit. A great way to capture this is the KublerRoss Model, 5 stages of grief, where you go through different stages before you finally accept your new fate. So in the beginning, there's denial. Go doesn't like generics. I can just use the empty interface, right? Maybe not. So as Rob Pike famously said, the empty interface doesn't say anything. There is no type associated with it. And as such, if you use it excessively, your code might be more prone to error. Then comes anger. That's not fair. Why me? Why did I have to fall in love with a language that doesn't have generics? Bargaining? I don't need generics. Sometimes code duplication is better than unnecessary abstraction. Why should I write 100 lines of code just to avoid copy and pasting 10 lines of code once, twice, thrice? Then comes depression. In this state, the individual may become silent, refuses code reviews, and spends much of the time mournful and sullen at his desk. For this inner void, there isn't even a nice gopher to represent this. But then eventually comes acceptance. Go doesn't have generics, but I can code my own parametric polymorphism by writing the tools to generate code I need automatically. And yes, this is literally riding the unicorn in the universe, and it's spewing fire. So let's look at the use case. Let's assume you are, for the sake of it, also working in a startup and building a social network. And trying to innovate in the space of social network, you have to be pretty crazy to begin with, because you have to be very innovative. You need to try out a lot of new different things, see if people like it. So you're working on the REST API in Go. And let's look at an example project structure. There's an API package which contains all the API information. We also want to have a client package so we can talk in Go to our own API. We have model, we have a server for the HTTP server, we have a data store and such. Our API is structured as follows. There are different endpoints, and we represent our API as an interface. And every API method has a very same structure. There's the method, then comes a context, a request specifically typed to that method, and for the response as well. So you would define the request type with its different parameters and JSON tags, and also the response as well. This has the advantage that whenever you need to change something in the API, adding any new field or removing anything, at least you don't need to update the method signature below. So coming back to our use case. So you're working in the startup and you're at your desk just writing the newest feature that they're demanding. And while you're implementing, at the same time, there's a meeting in parallel going on and they're already deciding to scrap that feature again. But yet management wants what? Well, they want that every new feature gets deployed immediately to production. The API should be production grade, so they want great observability, logging. They want to know how fast are the requests being processed and such. So how such a thing is usually achieved is using API middlewares. An API middleware allows us to wrap endpoints for executing code before, but also after the endpoint has been processed. So that might be a logging middleware to log requests, responses, and metadata. Instrumentation, so we want to know how fast are the 99th percentile of our requests executing, how many requests are there, how many errors at any given time. Tracing becomes interesting if you're working in a service-oriented architecture. The request might pass several services before being processed, and if you need to debug it, you need different kind of data in order to debug it. And something we found useful is activity recording. Basically, for every API request that's being processed, we want to have an entrance in our database. This is really useful because when you're recording that much data, then you can always derive a lot of data if you're adding new features and such. How would such a middleware look like? So, for instance, for the instrumenting middleware, it would be a pretty thin wrapper around our API interface, and some data structures to keep track of certain metrics. So the constructor itself, the implementation isn't as important as the method signature, because the important part here is that we are returning, again, the interface type. What does that mean? Well, every time we're adding a new API method, our Go code would error out. That way we can ensure that whenever we add a new API method, that we'll have code in place that will ensure that all the API methods are instrumented at any given time. And the implementation, it's also pretty straightforward. I think one thing I want to point out here, if you look at the code, what we're doing here is we are delegating the call to the actual API method, which contains our business logic. And before we are setting up a defer method, which will measure the request speed, check if there has been an error, etc. And I think it's important to point out that this is a lot of boilerplate code. There isn't so many parts that are different for each of these API methods. How would we instantiate something like that? Well, we are setting up all the dependencies. We are instantiating our API, and then we're just wrapping it around. And since it's still the same type, we can just reuse the existing variable. So all the middlewares, you just keep on wrapping whatever you need. You can also decide if you only want to wrap certain middlewares in certain environments and such. But as you can see, this is definitely a growing beast. And as you keep adding more files to it, you'll end up with more dependencies. And it doesn't stop here, because as I've said earlier, we also have a client package we want to support. So we have a HTTP client, and for each API method, again, we want to have a method satisfying the interface. Again, this helps us. If we make any changes to the API, our client will always be up to date. And here as well, the implementation isn't really that interesting. It's really creating a new request, setting it to the appropriate endpoint, performing the connection, doing error checks, and then also again like decoding the response. For the server, on the other hand, we want the same thing. We want to decode the parameters, possibly do some request validation if the data is appropriate, and then delegate the call to our API. So where does this bring us? Basically, in such an environment where our requirements are under constant fire, our API does change all the time. So if the request parameter and response fields change, that might be not as big as a problem because we've already extracted away that problem because we're having always one type and that type doesn't change. But for instance, if you're supporting API documentation, this might be a problem as well. If you're adding new features that result in new endpoints, then you need to update all of your files. But also, the other way around, it's also a bit problematic if you're deprecating features. This is not as bad because your code will most likely still compile, but you might end up with a lot of dead code which isn't used anymore, and this just makes the whole development experience a little bit awful as well if you have to skip over a lot of code that's not needed in the first place. So what does this mean for our project? Every time we touch our API.go file, we need to perform a lot of other changes. We have 4 middlewares, 1 server encoder and decoder, 1 client library. So you're adding new methods to the API every time, and you need to update 6 files all the time. So 6 files. This doesn't even include tests. Don't bring me there. I mean, this is awful. There needs to be a better way. And we're computer scientists, so we know there's always another layer of abstraction we can add. We know this isn't always a good idea, but sometimes it's really, really useful. So this brings us to code generation, our antidote in some ways. So hands up, how many of you have heard of code generation? Okay, still keep hands up. And how many of you have used a tool that has code generation? Okay, now more hands have gone up. That's odd. Okay, and how many of you have implemented their own code generation tool? That's plenty. Okay, cool. So let's look at the general architecture of code generation and its idea. So there's always a model, and we have a tool which makes use of templates. These templates contain our code, and given our model, we use the templates to create a lot of different code that we would need to write ourselves otherwise. And why does code generation exist? Well, there are different reasons, but in many cases, it's about working around the limitations of a language. In the case of Go, it can be generics. And the idea is to delegate tasks to write boilerplate code to a machine. Because if you ever write boilerplate code when you're sleep deprived, and never be sleep deprived, always sleep enough. But in case you are sleep deprived and you're writing boilerplate code, it's very likely that you'll make errors, and the machine is just much better at this. And I don't know about you, but if I'm doing a task over and over again, that's my personal definition of crazy, and I just find it mentally much more satisfying to spend my time doing meta-programming. So yeah, my general appeal to this is it can speed up a lot of stuff, and it's less prone to error. So the Go binary comes with a subcommand called generate, which scans the packages for generate directives. And each directive, the specified generators run. And if files are named, they must be Go source files. And generation happens only for directives in those files. So that means if you would put this line here at the top of your Go source code, and you run Go generate, then it would do just that. It would just invoke what we've defined after that statement. And that seems like awful simple, right? I mean, it's basically a function that takes a function and then invokes it. But the interesting part is that it's also setting an environment variable called GoFile. So if we were to run our command API gen with GoGenerate, then we would see that it's passing us the relative path of the file containing the generate directive. And that's super useful, because now we can automate. So let's do that. So let's look again at our boilerplate code, in the case here, our instrumentation middleware. So which parts do really change here? It's really just these things. We have the method name, we have the request type, we have the request response, we have maybe even other symbolic uses of our API method, but from a token point of view, it's still the same string. And the same goes for the eventual API call. So again, our generate architecture, we can call go generate, and we can also call it with the shorthand of using / and 3 dots, which is short for all given packages. This will ensure that all Go generators are run. It will invoke all the different Go generates directives and invoke a tool which we are providing, and it's passing the file name as environment variable. And the task of the tool then is to parse files containing the directive. After it has been parsed and we've created our model, we want to then again parse templates and pass our model to those templates to then eventually create the boilerplate code. So how do we go about parsing Go files? There is the Go AST package, and the AST package declares the types used to represent the syntax tree for Go packages. An abstract syntax tree is a tree representation of the abstract syntactic structure of source code written in a programming language. Each node of the tree denotes a construct occurring in the source code. So that's great, because that means we can now programmatically access our Go code and work with it. That's all we want, really. And there are only two main important methods here, and that is parse file, which is used to create the AST by parsing an actual Go source file. And then we have AST inspect, which does all the heavy lifting, because this one iterates just over all the nodes and allows us to extract further data. So let's bring again back into memory how our API.go file looks like. So we are seeing basically we have all the necessary information here. We don't even need necessarily the method itself, because if you see the way it's structured, we only need to parse at least one of the request or response type, because we can just slice off the string and we already have the symbolic value we need for our templates. So how would the parser look like? The parser creates a token set. It parses the file. Then we are passing the Go environment variable here. And then we start the inspection process. And because inspect takes as a parameter a very generic type called AST node, we need to do a lot of type assertion to see what types we're dealing with. Are we dealing with a function declaration? Are we dealing with a package declaration? And in our case, we're interested in the type spec because we want to read out all struct definitions, which there are. So parse type, if we already encounter a struct type, we want to check, has it the appropriate suffix? In our case, we are interested in a request. And we just slice off request, and that's it. We have our endpoint. We can add it to our model. And we don't even necessarily need response. So in general, if you're writing these kind of tools, you want to ensure that they are coherent in some ways. So there should, for instance, always be a request-response pair if these are your constraints. Templates. Who of you has used templates so far in Go? Okay. So this should look familiar to some of you. And one thing I would always tell, if you're generating code, include a directive, something like this, code generated by whatever, do not edit. This is basically for your colleagues who haven't written that tool and who shouldn't edit this code because all the changes would be lost eventually. It's also useful to include where the model was coming from, or where to find the templates in case you need to update it, because in general you'd rather see the Go source code rather than the template. And then when it comes to the boilerplate code, we only need to write it once, because here we are iterating over our model. In our case, these are the different endpoints. And then we're just replacing all the parts we've just identified. And since it's purely symbolic replacement, we also here need to replace it inside opening double quotes. And yeah, that's basically it. On the side of our parser, we need to read the template file. We need to parse it as well to see if it's syntactically correct. And then we can start generating our code. So in generate code, we would execute the template. And most importantly here, we are pushing our model to that template. That can be anything really. And that's a nice thing. You can structure it in the way which is most convenient for you to access the data in the template. And then every one of us uses either like Go format or Go imports when you're writing code, and I mean that's one of the reasons why we all love Go, because we don't need to care that much about indentation and how things are looking, because these tools take care of it. And when you do code generation, that's also something you shouldn't need to deal with. So you can just call any of those tools you are interested in a programmatic way as well. Here in this case, it's using Go imports. And before it's finally writing the generated code file to a file, it's processing it and is ensuring that all the Go import statements are there. This also includes some error checking, and as well as making sure it looks nice, because if someone else would touch that file and then suddenly their editor would reformat, then that would create an unnecessary commit. So let's take a look how this would look live. Okay, so here's our project. We have api.go. We have our different endpoints. And let's look at our middlewares. So for instance, logging. As you can see, there are middleware methods for each of those. And now we're interested in adding a new endpoint, right? So what should we add? Let's say we want to allow people to follow other users. So we're adding a follow user endpoint. Again, another method for our API interface. And that means we need to create a new request struct. We want to identify the user we want to follow. The response type can be empty for now. And as well as for the method, we can mock that for now. Don't care about it. Okay, follow user is not a type. That is correct. There should be request here. Oh yes, good point. Should be endpoint here. And then there's also something wrong with follow user response. Follower, no, we want follow user response here as well. Okay, so we thought we finally fixed all the errors, but as you can see, there's like our middlewares are complaining now. And as I've promised you, all we want really is call go generate. And our errors are gone. So let's look. Has it generated? Yes, we have now a follow user instrumentation method for logging as well. Recording too. Okay, so this has really done everything which we were interested here in at that point. So this is, in a way, a really basic way you can use it. So, but maybe should we get a little bit crazier with this? Thanks. Okay, so because we have so many data at hand there, and like the nice thing about this that we can use one file as our single source of truth. So why not put even more information there? Because that would mean every time someone needs to deal with our API, we can put all the important information there. And another important thing is documentation. So we could go as far as generate our own API documentation using GoGenerate. If you think about it, we can add a comment to our API method, we can add comments to our struct fields, we can add comments to our responses, we even can add like a couple of request examples which make it a lot easier for the users of the API to use it. And what that means, every time someone changes the API and at least adheres to like updating comments properly, if that's the case, then it means that we will always have up-to-date API documentation. And I think that's really great, especially when you're working with a lot of different developers and they are not always able to get up to speed with all the changes that are going on in the code in our API. So let's see what additional changes we would need to do in order to get there. So we have our parser, and parse file in addition takes fourth argument, which is currently 0 here, but it's actually a mode, so we can add different modes, and another mode is called parse comments, and there are a couple of other modes as well. And parse comments is important in order for us to get our documentation. So now it becomes interesting to parse the function as well. And we're doing some type assertion, we are extracting the name, and we can also access the documentation. And then there are some additional checks like, okay, is the method defined actually part of API and such. For the parameters as well, I've shown you before that we had the struct type, and we can just iterate the fields and extract the documentation here as well as retrieving the JSON type, and maybe also mapping some types which are not as appropriate to just display in the API documentation as they are displayed in the Go source code. So if you ever go out and decide to do code generation, write your own tools, there are some best practices I would give to you. The first one I've already mentioned, like include something like a do not edit line in your templates for your collaborators to see. Another thing about GoGenerate, it is intended to be used by the author of the Go package, not its client. So by that also means that you should commit the code created by GoGenerate into the repository. So if someone checks out the code, they shouldn't need to run GoGenerate in order for the code to work. And don't be afraid to generate your unit tests too. This might not seem like reasonable. I mean, surely it will increase your test coverage, but it might also uncover some edge cases you haven't thought about. And lastly, and most importantly, make your code generation tool robust. Otherwise, your colleagues will hate you, because it should be easy for them to use it, and it shouldn't break the whole time just because you're not working with it in the most current way. So yeah, as a summary, GoGenerate is a meta tool that you can use as a building block to avoid building your own tools. Basically, build a tool that's fitted for your purpose. And again, like, this may be very different, and mileage varies as always. So maybe you think like, what did he show us here? Like, why is he doing the API middlewares in such a way? Like, I'm sure I could implement it in a better way, and that's totally fine. Like, if there's one thing I want you to take with this is when you come back to your work, try to see if you do any repetitive tasks, identify them, and try to figure out if you can extract the essence of that into tooling. So. Also, I really would suggest make that tool part of your existing automation as well. So run it in your CI/CD pipeline. That will ensure that it will always be executing properly and that there aren't any errors which you might have overseen. And yes, well, deciding to write such a tool means also it can break. So it's another tool in your stack and it might require maintenance. So this is also something to consider if you want to automate it. So put that into consideration as well. Okay, that's it.
Thank you so much. Questions? Wow, a lot.
Good day, Robert. Thank you for the great talk. One question that I've always had with Go Generate is why do we even need a separate command and why not just use makefiles?
Right. Well, Makefile isn't necessarily part of the Go ecosystem, and it's just a tool from a different period. I would assume you could do similar things with Makefiles as well, but I mean, Makefiles are more for build process and automating that part. And Go Generate is supposed to be part of the Go command line, and yeah, it's coming with its own tool. But in theory, there isn't necessarily something that would, I mean, using the package shortcut, for instance, you would need to implement that yourself with Makefile, whereas Go already automatically unfolds this into all packages. So yeah, there are a couple of reasons, I suppose.
Hello. My question is why don't use Open API definition to generate service stubs and client stubs and make middlewares on the higher abstraction level, like wrapping HTTP server interface but multi-method API interface?
Could you repeat the last question once more?
Last question. When you're talking about middlewares, 4 types that you have, you are wrapping every method of API interface. Yes. But I think usually middleware can wrap HTTP handler interface that has only one method, and right. It is good enough.
Right, okay, so to your first question, I haven't worked with OpenAPI. I'm pretty sure that there are ways which not necessarily make the work as necessary as we've done here. This is also an extracted example because on October, for instance, we have our own WebSocket framework, and that's different from HTTP. From a purely REST API, I've just like converted the project a little bit to make it more accessible. But in our case, we were using WebSockets, and I'm not sure how OpenAPI supports that part. But yes, in general, there are a lot of Go generation tools as well to support API needs. And to your second question, this is in particular for, if I got that correctly, about API endpoint middlewares, which should wrap each method because you might need to do different things in these API methods. Whereas I think you were talking about HTTP middleware handlers, which are more generically doing the same thing for everything.
Thank you.
Hi, I'm Dmitry, and I have a question about modifying generated code. You put block, do not edit this code. This code is auto-generated, but what's about decoding request? Maybe if some endpoints needs custom logic for decoding request, and how update this auto-generated code after that modified.
So I didn't quite get this. Did you mean about how to automate the update procedure?
Yeah.
Okay, so in order to automate this, what we've been doing is like we have our own build script which calls go generate before go build. So that's actually one important point to note. Go generate is explicitly different from go build because go generate won't do any checks in terms of dependencies as such, other than the files it might be calling. So you need to check that separately. So yeah, we are using a build script for that, and otherwise, yeah, make use of your CI/CD automation.
No. What's about updating modified auto-generated code, modified by programmer, if custom cases?
If what's not the case?
If needs custom decoding logic in endpoint.
Right. So basically, you don't want to use the generic produced boilerplate code, but want to override a particular one. Yeah, that's an interesting question. In this case, so there are different ways. We've also been using, so we are not always, sometimes we've embedded as well the API interface type into our struct, which means that it automatically gets the same methods. So you wouldn't need to implement each method, but you could decide to override only methods that you want to. So I would probably potentially make use of that. And otherwise, I would build that into the parser, our API gen tool, to basically skip certain implementations, and you would need to provide that. So you could, for instance, work with comments, where you add a comment like do not reproduce or something like that, and then based on that.
Yeah, comments could help, but if we need update, okay.
I'm sorry, guys. Let's move this amazing discussion for another time. So, Konrad, briefly pick the favorite question, and we will change the equipment meanwhile. Okay?
Okay. So, first question goes to you.